Welcome back. Let's do a capacitor simplification. So we're given this capacitor network. All these capacitors. There's a 5 microfarad, a 30 microfarad, a 10 microfarad, 4 microfarad, 3, 48 microfarad, 16 microfarad, and that's all the capacitor values in farads. But to make it more fun, they've given you the voltages across each one of these guys, and they're going to ask you to keep track of that. So there's 5 volts across this guy, and there's 10 volts across this guy, and there's 30 volts across this guy, and 10 volts across this guy, and another 30 volts across this guy. So they haven't given you all the voltages. Like this one here they're not giving you, and this one here they're not giving you, but they've given you all the rest, and they're asking you to find the single cap equivalent from AB. Just seen from AB, we can simplify this down to 1 cap, and they want you to find the voltage. Keep track of the voltage at AB, but let's, for more super fun, we're going to keep track of the voltage all the way across, just because it's a good exercise. And also, when we're doing more complicated circuits, we might simplify just part of the circuit, so we might want to keep track of the voltage in just that section. So that's kind of what we're going to do here. So so the final answer, by the way, we could sort of calculate the voltage anyway pretty quick, and I'm just going to do that real quick just to kind of, show you overall how that works. So look, if we start here, we're rising 30 volts when we go to this point, right? We're rising up 30 volts across here. So it's plus 30, then we're dropping 10 to this volt. So now we're at oh no, I'm rising, sorry. So we're rising 30, we're rising 10, that's 40. Then we're falling 30, so we're back to 10. Then we're rising 30 again, so that's 40. Whoops, I used the wrong number, so I used 30 instead of 10 volts. Let me start over again. All right, so here we're starting here, we're rising 30, then we're rising 10, so we have 40 volts. Then we're dropping 30, so now we're back to 10. Then we're rising 10 volts, so we have 20, and then we're rising another 5 volts. That's 25. So starting here and going all the way around, we end up with 25. So that should be the final answer. We should expect 25. All right, but let's do it element by element, just for more super good fun times. All right, so let's kind of start over here, and it's kind of best if you follow the voltage rises. So there's a rise of 30 here, and there's a fall here. But it's nice if we could kind of keep the values positive where possible. And if I go this way, I can keep it positive. So this little loop right here would be it'd be rising 30 and then falling 10. So that's 20 volts. Okay, rising from minus to plus, rising 30 volts to this point, and then falling 10 volts. So the total voltage change is 20 volts. Then let's combine the capacitors. So now we're doing capacitor simplification, so the rules are flipped over from resistor simplification. you treat parallel like series and you treat series like parallel. So I kind of have a notation for that. I'm trying to simplify a 16 in series with a 48. So I write SER, and it's really just the product over the sum. This is just a notation that I like to use for simplifying capacitors. So we're using the same rule that we use for parallel resistors, which is the product over the sum. But I can't write the parallel, because that would be a little confusing. So I write this. So to be clear, this is 16 times 48 over 16 plus 48. Okay, that's what I mean by this SER notation. And that ends up being 12 microfarad. Then what I have is this 12 equivalent from, well, let's call it nodes, between nodes C and D. I have a 12 capacitor, a 12 microfarad equivalent in parallel with a 3. So you can just add those. So 3 plus 12 is 15 microfarad. Okay, so between C and D, it simplifies down to a 15 microfarad capacitor with 20 volts across it. And then we can redraw at that point. Okay, the 30 is still here, and there's no D. This is the 30 microfarad with 10 volts across him. And we replaced all this other junk between C and D with this guy here, with a 15 microfarad cap with 20 volts across him. So we're rising 30, falling 10. That's like rising 20. Right. Then we'll continue. So we have a 30 in series with a 15. So you can write 30 SER 15, and then do the product over the sum, and you end up with 10 microfarad. And then voltage. Let's just go around this way for the voltage. So we're falling. Let's see, we're falling 10 and then rising 20. So it's minus 10 plus 20, which works out to be 10 volts. Okay, so let's call this node E. So we simplified some stuff between E and C, and let's redraw that. Yeah. We simplified all the stuff between E and C, and this is what we came up with here. Well, actually, not all the stuff. We just simplified these two guys. I didn't do the... it's possible to do another simplification with this guy over here, but I didn't do that. So, that's why I'm saying you got to be careful when you redraw these. I mean, the best thing to do is redraw the circuit after every single transformation. That way you're not gonna get lost. But I just did these two, so I didn't throw in the 10 microfarad. He's still there. So let's just go with that, and just to show you different ways to do stuff. Okay, these three guys are the same, and then I simplified these two, like as shown over here, and the result was a 10 microfarad with 10 volts rising. Okay, so just one more time. Like up here, I did a series simplification, and then I continued and did a parallel simplification, and then replaced those guys with this guy. But then I just did a series simplification. I replaced it with here. I didn't go the extra step and do the parallel. So like I say, if you're confused about that, then redraw the circuit after every single, take 2 capacitors, combine them, redraw, and then 2, combine them, redraw. That way you're not going to get lost, probably. Yeah, it's a lot more work, but anyway. So here we have these 2 guys are in parallel, so I can write 10 in parallel with 10 is just 20 microfarad. Here I used plus because that's what you're doing with parallel, just a different notation. And the 10 volts is still 10 volts because this element is in parallel with this element, so they have the same voltage across them. That's just kind of a circuit's rule thing. Items, elements in parallel have the same voltage across them. Okay, elements in parallel have the same voltage across them. So I think that's the point of doing just the one simplification and then redrawing, so that we can point that out, that these 2 guys have the same voltage across them. All right, what's next? Oh, well, these 2 guys are in parallel with each other. Yeah, so we just added them together and simplified that down to 20 volts, but it's still 10 volts. So let's redraw with this simplification that we did right here. So yeah. So here's A, here's B. Okay, combining these 2 to get the 20 between E and C gives you 20 microfarad and 10 volts, right? And then the other 2 guys, throw them in there. 5 microfarad, 4 microfarad, 5 volts, this polarity, and 30 volts, this polarity. And then we have 3 guys in parallel. No, series. 3 guys in series. 3 guys in series. So the equivalent of this is going to be 1 over 1 over plus 1 over plus 1 over, right? The 5, the 20, and the 30. Oh, sorry, the 5, the 20, and the 4. 5 microfarad, 20 microfarad, 4 microfarad. This is the formula for resistors in parallel or capacitors in series. And you can do all 3 at once with this formula, right? And that ends up being 2 microfarads with a value less than any of the others, which is kind of a double check on this kind of thing, that the answer you get is going to have a final value less than the smallest of these guys. And then the voltages, we can just sum them. So here we're doing a minus, we're dropping 5 because we're going from plus to minus, so that's going to be minus 5, and then we're rising 10 because we're going from minus to plus, and then we're dropping 30, so it's going to be a negative 30. So the voltages work out to be minus 5 plus 10 minus 30, or minus 25 volts, going around this way on the voltages. Okay, so that's our answer. Our answer is a single capacitor with 2 microfarads and 25 volts, and it's from A to B, it's a drop, so we want the positive sign up here and the negative down here. That's it. All right.